Hi, everyone. It's my first time at Gathering for Gardener, and I'm really sorry that I can't be there in person, but hopefully next time. My name is Philipp. I'm the founder of Mathigon. Our goal is to make online learning more interactive and engaging than ever before, so that students can explore, discover, and be creative, not just memorize information or solve multiple choice questions. I'm going to share or show you some parts of what that looks like. Mathigon contains interactive courses for middle and high school students on all sorts of different topics like Fibonacci numbers or fractals, the Monty Hall problem, map projections, the Königsberg Bridges problem, and much more. And with all of these courses, we want students to explore and solve many different puzzles and open-ended activities rather than just being told how these things work. There are different games and libraries of puzzles. We've got a timeline of mathematics if you're interested in history, with many different biographies and interesting mathematical artifacts, and many other activities from origami instructions to treasure hunts around schools. But what I wanted to talk about today was Polypad. We call Polypad a mathematical playground. You can almost think about it as a Lego kit for mathematics, with hundreds of different tools and features to explore and be creative. And I'll start with a very short video just to give an overview of some of the things that are possible in Polypad. So we've got all sorts of different polygons and shapes, a 3D library, and you can make your own three-dimensional shapes, dynamic geometry, many other geometric construction tools, many different ways to visualize numbers in different ways, like these dots or exploding dots, graph plotting and algebra tools, data science tools, playing cards, probability tools, and a lot more. So what I'll actually do is I will switch to my browser to show you some of these features in practice. Polypad, like all of Mathigon, is completely free to use. You don't even need an account unless you want to save your work. So I really encourage you to play around with it. And we have many tools here in the sidebar like Tangram or polyominoes that have appeared in previous talks. But I wanted to start with these polygons. I'll just drag out a few of them onto the canvas, and all of the vertices and angles should snap to each other so that it's really easy to create tessellating patterns just like this. And we can repeat this a couple of times and then maybe fill in the triangles later. But what we can also do is create nets of three-dimensional solids. So here we've got the net of a prism. I'll zoom in a little bit. And if I select all of those shapes and click Fold Net, it'll automatically turn it into a three-dimensional object I can play around with and rotate and unfold if I want to look at how it works. Or we can use the pentagons to create maybe just one vertex of a dodecahedron. Or let's do, how about one half of a dodecahedron like this. And again, I'll select all of them and fold them, and then we've got a three-dimensional shape to look at. So with the polygons, we have any net you can create, we can fold into three-dimensional solids, but you can also make your own shapes. So we have these custom polygons. Let's turn on the grid background and maybe create a larger square using this custom polygon. And I will lock this in place. Now I can use the cut tool to cut this into a few different parts. And let's do this twice like this. So we have 4 equal parts, and I'll disable the grid again. And now let's try to rearrange all of those shapes a little bit, and we need to rotate all of them just a couple of degrees like this. And we've got a little magic trick how we can create a square into another square with a hole in the middle. So all sorts of different things you can explore with these polygons. We've got Penrose tiles, we've got all different possible pentagonal tessellations, and a lot more. But there are many other types of visualizations. I showed some of the number expressions before. So if we create maybe 21, 2, 3, 4, 24 as a shape of squares like this, we can explore different factorizations. And if we do the same with 23, students can discover what prime numbers are because they can't be formed into into rectangles. There are lots of different visual representations of numbers, like these prime factor circles that you can drag apart. So if I take a 2 out of the 16, I'm just left with 8. And if I drop a 14 onto the 2, I get 28, and so on. Fraction bars, algebra tiles, balance scales, all sorts of things. My favorite tools are the probability tools, so I can very quickly create some spinners, add lots of dice to the canvas, and then let's select just those, randomize them. You can add tables and create your own data visualizations by linking those together. And just in the last couple of seconds, I will show you the latest feature we added, which is logic gates. So we can add some of these switches, maybe an OR gate and a light bulb onto the canvas and connect all of these together. And if I turn one of the switches on, the light bulb also turns on. So yeah, hundreds of features. You can play chess within Polypad. You can save all of your work. So you can see I have lots of saved canvases of certain tessellations I've created or tangram shapes. We also have lots of examples down here if you're interested, like fractals or different ways to create dodecagons using pattern blocks and a lot more. There's a library of more than 100 lesson plans for teachers to explore with Polypad, and we just can't wait to see what you do with it. Thank you.